So what I have up here on the board is some things that I was going to go over to kind of remind you about some definitions and some things that you need to know for the test over Chapter 11. The test over Chapter 11 is on ProProfs. It does have like some of the pictures, graphs, tables, whatever. So you gotta make sure you're looking at those and you know how to read those correctly. Now, on here, some of the first things is some of the multiple choice stuff on the first page. It's just about our different types of probability. So remember, we had like two different things. We had discrete and we had continuous. Discrete means it can be counted, and continuous means it must be measured. So continuous was like, it had to be measured. That's like when we had the uniform probability distribution, and you had like the little things over there, and we had the how many boxes it filled. We had to multiply by how tall each box was. We had to measure, we had to get the area. That's how we found the answer on those. Another common problem that you have on the test is like this right here, where it gives you like menu options or different colored jelly beans in a bag or different colored pens or whatever it may be that you're drawing out. So on here for the menu, they can have chicken, steak, or fish, or they can have broccoli, spinach. They have two different types of carrots, and there's two types of breads to choose from. Okay, so I'm going to do the probability of a bread. So I said there's how many choices of bread to choose from?
Two.
Breads. Okay, there's 9 different items up here total. 1, 2, 3, 4, 5, 6, 7, 8, 9, because you had two types of carrots and two types of breads. So when I go to do this, I'm just going to put 2 out of 9. That's my probability. Now, if I can reduce it, I reduce it. Otherwise, we usually had to write it as a decimal with how many decimal places?
3.
3.
3. So when you do that, you get 0.2 repeating. So it would just be 0.222. So something that you need to make sure you do on the test is that you have the correct number of decimal places. It tells you in the directions for that problem or that section, it'll say round answers to 3 decimal places or round to the nearest hundredth or whatever. It'll tell you how many you're supposed to have. So make sure you pay attention to that. Now, on the next one, it says probability of choosing either steak or broccoli. So you only have one choice of steak. You only have one choice of broccoli. But it has the word or. When it has the word or, do we add the things together or multiply them together?
Multiply.
Nope.
Add.
When it says or, we add. Because you can have steak or broccoli. You're not having both together. So I have 1 chance out of 9 of getting steak. I have 1 chance out of 9 of getting broccoli. So that's 2 ninths. So it will also be 0.222. Okay, Markeith, what I'm doing is I'm going over some examples and stuff to help for your test when you log in to take your test. Okay, so on this one, probability of spinach or a vegetable. Okay, spinach, you have 1 chance out of 9. How many vegetables are there? Is spinach a vegetable?
Yes.
Yes. Are carrots vegetables?
Yes.
Is broccoli a vegetable?
Yes.
Yes, so these are all vegetables. So there's 1, 2, because I have 2 types of carrots. 1, 2, 3, 4 vegetable choices. So there's 4 vegetable choices. And then spinach is also a vegetable, so since it's both at the same time, can I count it twice?
No.
No. Remember, this is what we called not mutually exclusive because spinach is a vegetable. Since spinach is one, it's not mutually exclusive. So I have to subtract that chance of having spinach back off there because I can't count it twice. So I have 1/9 plus 4/9 is 5/9 minus 1/9 is 4/9, and then you do it on your little handy dandy calculator. 4 divided by 9, and you get your decimal for repeating. So it will be 0.444. So this, remember, since spinach is one, I said it is one that is not mutually exclusive. Okay? Now, what if I said broccoli or something that's green? Is broccoli green? Yeah, so I would have to take that back off. Okay? But spinach is also green. So I would have broccoli, one choice, 2 choices for green ones, but then I'd have to take the one broccoli back off. I can't count it twice. Okay? Those are not mutually exclusive. It can be both at once. Okay? So if I said the probability of choosing a Relly or a 9th grader, a Relly's a what?
9th grader.
9th grader. So that's not mutually exclusive. I can't count her twice. Okay, so mutually exclusive is like steak or broccoli. If it's steak, it's not broccoli. Trust me, steak is definitely not broccoli. Broccoli is definitely not steak. Okay, they're 2 separate things. They can't be in both categories at once. Okay, so that's what that's talking about. So these are some of the questions that you have on there. Now, I've got another one down here, except on this one it says the probability of having both fish and spinach. So this time they're taking 2 things. Okay, since they're taking 2 things instead of or, they have and. So when it has and instead of add, we do what?
Multiply.
Multiply. Remember, we usually use the dot for multiplication in algebra, so we don't think it's a variable. Okay, I'm trying to scoot a little closer because some of y'all are like, I can't see. So there we go. All right. Plus, I'm losing the calculator. Everything else going on. All right, so we have this probability of fish and spinach. How many choices of fish were there? 1. There was 1 fish out of 9. How many choices of spinach were there? There was 1 spinach. 1 out of 9. Except this time it's multiplying. So when you multiply fractions, you multiply straight across. 1 times 1 is 1. 9 times 9 is 81. And then on your little handy dandy calculator, you take 1 divided by 81 and get a decimal. It's a big, long, repeating decimal. Remember I said we're keeping how many decimal places? 3. It always asks for 3. So it's going to be 0.012. Oh, look, it goes 0.0, 1, 2, 3, 4, 5, 6, 7, and then 9. All right, so it almost goes in order. So 0.012 is your probability of having fish and spinach. Now, on my next one down here, you're eating something and then you want something else. Okay, so I'm eating bread. How many choices of bread were there? 2. After I eat the first piece of bread, I decide, I want to try that other bread. How many choices of bread are left for me to choose? How many items are left for me to choose from?
8.
8. So it's 1 out of 8. These are what we call dependent events. This is when it says no replacement or without replacement. If you eat it, you can't get it back, or we don't want it back. Let's put it that way, okay? If you've eaten it, it's gone. I think the one on the test has jelly beans. So if you ate the first jelly bean, do you have that jelly bean in there to pick from the next time?
No.
No, so you have to count down. So this is dependent. It has the word and still, so we're still multiplying. So I multiply 2/9 times 1/8. Now, you can simplify first if you want to. Okay? You can simplify first if you want to. 2 goes into itself once. 2 goes into 8 4 times. Multiply straight across. 1 times 1 is 1. That's an equal sign. I don't know what it looked like. And then 9 times 4 is 36. So you have 1 divided by 36. You get another lovely repeating decimal. It's 0.027777. Just the 7 repeats. So is that 7 going to make the last 7 go up? So it's
Yes.
028. Okay, so you have 2 sections of problems that are similar to what I just did here. This covers like 7 problems on the test. Okay, because you have one that has these menu items, and then you've got another one that's the jelly beans. Okay, so they're all similar to what we just talked about here. You got to remember, if it says the word or, you're adding the fractions together. If it says the word and, you're going to multiply the fractions, and you make sure you round to the correct number of decimal places. Okay? All right. Everybody got those? I'm just kind of going over some examples so you have them. All right. Now, something else that it has on the test is a table that looks like the one I did up here on the board, which is called a what table?
Frequency table.
Okay, it's a two-way frequency table because it's comparing 2 different data. Okay, it's looking at the books and the TVs, so that's one variable, whether they prefer books or TV, and then it's got the girls and the boys. Okay, so that's the other variable. So you've got 2 different variables. You're looking at these things. Okay. Now, on here I have down here, when you're looking at this, these here on the outside, these outside sections, okay, so the total part, basically is what I'm talking about, the totals are called the
Marginal.
marginal frequencies, okay, because they're in the margins. Okay, margins, remember, like the edges on your paper, when you're typing a paper, you have to set the margins, the white space. Okay, these are, it's on the sides. These are your margins, your total columns and rows. Okay, the stuff inside is called the
Joint.
joint frequencies. Whoops, sorry. I just scared myself. I pushed my marker too hard. It popped. All right, so I have joint, okay? So you have 3 questions. That's all it's asking you to do. It's asking, are girls who prefer books a joint frequency or a marginal frequency?
Joint.
Joint. Are the total number that like TV, is that a marginal or a joint?
Joint.
Marginal.
Marginal.
Marginal. If the total number of boys, would that be a joint or a marginal?
Marginal.
Marginal, because it's the total number of boys. If it's in one of these bottom rows or columns, it's one of your totals. So it's marginal frequencies, okay? Now, if I simply say, how many girls prefer books? You just look at the table and you tell me how many girls prefer books.
8.
It's 8, so you just put 8. If I say, how many girls prefer TV, you would tell me
6.
If I said how many boys were there total, you would tell me 18.
18.
Looking at the table and answering the question. Okay, so you have a 2-way frequency table like this on the test where you're just answering questions. Okay, now, another thing. If I want to know the conditional probability of choosing a boy who prefers books. So I'm saying, what is my probability out of all the boys that I will choose one that prefers books over TV? So you got to look, how many boys preferred books?
8.
How many boys were there total?
18. 18.
18.
So if I want to know the probability of choosing a boy who prefers books, that would be 8 out of the 18 boys. So I have 8 over 18, and then I simplify that. So 2 goes into both of them. So I get 4/9. So I'm going to get another lovely repeating decimal. It's going to be 4 repeating. And since it's 4 repeating, I'm talking about probability. We usually have 3 decimal places. So it's
444.
Okay. Yaneli, I'm going over some stuff up here on the board to help as examples for your test for chapter 11. Okay. Now, this is just a little side note in here. Okay. If it gives you the relative frequency table, that's the one that looks like this, but it has percents in it. If it gives you the relative frequency table that has the percents in it, when it asks for the probabilities, you got to change them back to a decimal.
Decimal.
So you got to move your decimal point 2 places to the left. So if it was 8.5% in the table, then you put 0.085. You still keep the 3 decimal place rule. Okay? And then you have another set of questions on the test that's about the geometric probability. It has like this picture that's like a target or something, and it's got different shapes on it. Like I think there's 2 different size circles and a triangle and a rectangle maybe. But anyway, it gives you the areas of those, okay? So if I want to know like the probability of hitting a triangle, I would take the area of the triangle, which it gave to you, and I would put it over the area of the whole thing, whatever it was. You divide it, you still get the 3 decimal places answer like any of the other probabilities. Okay, so those are some things that hopefully can kind of help you on the test. Now, not many of you had even tried to take it yet. If you did try to take it, like I said, I will go back in there and reset it. So if you want to try it again, maybe after this you realize some things you may have messed up on. Okay. If you had already looked at it, is there anything that you remember that you still can, like, I had no idea how to do that, that you want to ask me about? I don't think very many of you had even tried it, so. Okay. But I wanted to go over a little bit more. Plus, remember, in your My Schoolworks email, I had some stuff on that email, too, about, like, the criteria to be a valid probability, because you had a couple of questions that were about that on multiple choice and that kind of stuff. Okay? But please, please, please don't forget to go in and take that test. Questions on those? Okay. What we're going to talk about today is we're going to start on statistics. Okay? Last chapter was mainly probabilities. Okay? Usually they put probability and statistics together as a class of mathematics. Okay? So that's what we're going to be talking about next, section 12.1. Okay, so if you get your book open, it's page 551. Section 12.1, page 551. Okay, y'all ready? Everybody's on page 551?
Yes, Mom.
All right. Roll around this way. All right. Now, it says we're doing the teal, but there's only like 6 problems that are teal. Okay, so it's not that many. Each one has like 4 parts, but a lot of the first 3 on those, you're just reading the situation and identifying the different things. But to know what we're identifying, oh, it's not page 551, my bad. It's 552. I didn't think that sounded correct, right? Okay. We got to go through some definitions here in your book. Starts on page 552, statistics. Okay. So some basic definitions is statistics is the study of techniques for collecting, organizing, analyzing, and interpreting numerical information. Okay. Descriptive statistics are used to summarize the main features of a collection of data. Okay, so that's like when we're talking about average, that type of stuff. Inferential statistics are used to draw a conclusion about a collection of data. Okay, so descriptive, basically summarize or describe the data. Inferential means we're making conclusions about the data. We have different types of groups. These are getting into our definitions that we need for number 1, 2, and 3 up here. The bottom of page 552. Most accurate information comes from studying a population, which is the entire group, but you can't ask everybody, okay? So a lot of times, this year is the census year. Y'all know what I'm talking about with the census? A lot of your parents have probably already filled it out. We haven't because we're slackers. But anyway, the census, they do it every 10 years. It asks everybody in the population to fill out, talking about who you are, how many people live in your household, that type of thing. It's how they find out the population and stuff for different countries, etc. Okay, so a lot of times you can't ask everybody. So they do a sample, which is a selection, a smaller group out of the population. Now the sample size is the number of individuals that we include. And then what we are studying is called our variable. And it can be a quantitative variable, means it's a number, or we can represent it qualitatively, which is in a category, okay, where we put them in different categories. So there's quantity is number, quality is category. And then we get into even more definitions, but we'll use those for the last 3. So let's flip to page 557. Because we're going to focus on the population, the sample, the variable, which is what we're studying, and then whether it's quantitative or qualitative. Okay, so for number 1, on page 557, it says Jennifer measured the breadth of the palms of 40 out of 214 students in her high school. So part A wants to know the population. So if I'm talking about the population, I'm talking about everybody. So how many are there total in the school?
214.
So that's the population. The population is the whole thing. Then part B wants the sample. That's how many she actually measured. And it was how many?
40.
So that's 40 students. Okay, so population is the entire thing. Sample is how many they looked at. Now, what was she actually measuring? What was she looking at? It said the breadth of their palms. She measured how wide the palms are. Study. That's what she was doing. That's what she's looking at. Okay, this is who she's trying to get an idea about. This is the one she actually looked at. This is what she was looking at. And then part D is where you got to be a little bit more careful with the quantitative or qualitative. Okay, so I'm going to read that part again. A characteristic that is being studied is called a variable, which can be either quantitative or qualitative. A quantitative variable is a variable that can be described by using a number, because it's based on the root word quantity. Quantitative variables can be further described as discrete or continuous, just like in chapter 11. Remember, discrete means it was counted, and continuous means it was what? Discrete was counted, continuous was?
Not counted?
Measured.
Measured.
Measured. Discrete was counted, continuous was measured. Okay? And then if it's a qualitative, that means it's categorical. So you'll just have, like, there were 5 that had blonde hair, 3 that had red hair, 2 that had brown hair, okay? You're dividing them by categories, not a number type thing, okay? So with measuring the breadth of the hands, is that going to be quantitative or qualitative? Is that going to be a number?
Yes.
Yes. So it's quantitative. Okay. So since it's measured, is it discrete or continuous?
Continuous.
Continuous. So if it's quantitative, you also have to tell whether it was discrete or continuous. Okay? So this is what we're doing on number 1, 2, and 3. You're labeling your population, your sample, what they're actually looking at, and then figuring out whether it's quantitative, a number, or qualitative, a category. Okay? Number 2. It says, Amber wants to determine which color is most often chosen by her coworkers as their favorite color. She asked 10 of the 31 people at her job. So your total population, Aurelie, was what?
31.
Okay, so 31 people at job. Yaneli, how many did she ask?
10.
Here. So her sample was 10 people. Okay. What was she asking them? Jazaria, what'd she ask him about? Jazaria.
I don't know.
Asking them about their favorite color. So that's the variable. That's what she was trying to find out. Okay. Since you're talking about colors, is that quantitative or qualitative?
Qualitative.
Qualitative, because basically you're just going to end up with people in categories. You'll have people who liked red, people who liked yellow, people who preferred blue, people who like purple. Okay, you'll have them divided by their favorite color category instead of actually measurements, numbers. Okay, so that was number 2. Number 3. It says Anne wants to know if she has fewer, the same, or more pairs of shoes than other women in her church. To find out, she has 7 out of the 25 of the women at her church. So our total population is 25 women in church. Apparently she has a small church. She only asked how many of them?
7.
7 members. Okay. Now, what was she asking them?
About their shoes.
So she was asking them how many pairs of shoes they had, right?
Mm-hmm.
Don't ask Mr. Pelham. He'll say I have too many. How many pairs? But anyway. And then part D, is it quantitative or qualitative? Is it dealing with numbers?
Yes.
Yeah, how many pairs? So that means it's quantitative.
Quantitative.
Okay. Now, is it going to be measured where it's continuous, or is it going to be counted where it's discrete?
Discrete.
Discrete.
Okay, good. It's counted, so it's going to be discrete. Good job. Okay, I'll move so you can actually see them. Okay, so pretty easy. Your first
Yes.
third row is your population. That's the total. Okay, then sample is what you ask. This is your question, what you're looking at, and then you do whether it's a number or a category. Okay, That's of what we were doing. First, you look at the whole group, then you look at the part you're looking at, what you're asking them, then you figure out whether it's quantitative, a number, or qualitative, a category. Okay? Now we're getting to our measures of center. Does anybody know what I mean when I say measures of center? You should, because that's something they start teaching you like in 7th grade. Anybody know? Any of these words sound familiar? Mean, median, mode? They sound
Yeah.
familiar?
Yeah, median.
Okay.
I didn't know it was called measuring the center.
Yeah. Measures of center, because they kind of give you an idea of where the data is centered. Okay, where it kind of, what it kind of goes around. So your mean is your average. So that's like what I do with your grades. I add up how many you got out of how many total, and I get the average. Okay. Median is your middle number. If you're talking about the median, though, they put them in order from least to greatest. And then mode is what shows up the most. You don't always have a mode. Every number shows up one time, there's no mode. If you have one number that shows up twice and everything else is there once, it's got one mode, or it's called unimodal. Uni meaning one, okay? If it has two numbers that show up twice, then it would be bimodal. It has two modes, okay? So you can have no mode, bunch of modes, okay? Now, another thing that they sometimes find that is not a measure of center is the range. And the range just is called, it's a measure of variation because it shows how the data varies, how far the data spread. So to find the range, you just take high minus low, okay? So we're gonna focus on finding our mean, our median, our mode, and our range for these last three problems. Now, some things you need to know is sometimes we have a data value that's way off from the others. Does anybody remember a name for that?
Outlier.
Outlier. Think of it as an outsider, okay? Everybody's inside, but it's outside, it's an outlier, it doesn't fit in with others. So if all your test grades are like B's and C's, and then you get a 25, that 25 is an outlier. That 25 is not gonna be good to your mean, your average. It's gonna bring your average down. It's not gonna really affect your median, your middle number much, and it probably won't affect your mode, the number that shows up in most. It's not gonna touch those, but it's gonna affect your mean. So the outlier has an impact on your mean, your average. It doesn't really affect the other two measures of center. Okay, so that's what we're doing on number 5, 6, and 7. So you have to flip the page, page 558. You're up here at the top. It says find the mode. That's part A. The median is part B. The mean is part C, and the range is part D. Label the mode as unimodal, meaning there's just one, bimodal, which means you had two of them, or no mode, there was none. Okay? Round answers to 3 decimal places when necessary, because a lot of times when you're doing your mean, your average, since you're adding stuff up and dividing, you can get decimal answers. Okay, so let's look at number 5. So on number 5, you have Lucas scored the following number of points at each game during the school's basketball season: 10, 19, 13, 16, 15, 14, 10, 7, 15, 10, 21. So if I want the mode, I look to see what number do you see repeated in there?
10 and 15.
10 and what?
15.
Okay, how many times is 10 in there?
3.
How many times was 15?
2.
2. So they're both not a mode because one of them showed up more. So only 10 is the mode because it was there 3 times. So you've got 10 and it's unimodal, okay? Because it was there still one more time than that 15, okay? Now for part B, you're finding the median. I said median is your middle number. But to be able to find the median, they put them in order from least to greatest. Are the number of points he scored in order from least to greatest?
No. No.
So we're going to rewrite them in order first. So the lowest number of points he scored was a 7. And then you had the 10s. There were 3 of those. After 10, the next number of points was a 13. There was a 14. There were 2 15s. There was a 16. What else was there? 19 and then 21?
Yeah.
Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I always double check and count to make sure I didn't leave one out by accident. Okay? So to find my median, my middle number, I've got 11. So I have an actual number that's right in the middle. So you can either count in from both ends. 1, 2, 3, 4, 5. So the exact middle number is that 14 right there. Or you can divide 11 in half and get 5.5. So you know it's got to be the 6th number, the one in the middle. So my median is 14. Okay. Now, my mean is part C, so we have to add them all up and divide by how many there are. We just counted, there are 11 of them, so we have to add all those numbers together and divide by 11. So on your little calculators, start typing. Y'all getting the same number?
Yeah.
Okay, so then you divide that by 11 and you're gonna get a decimal. It's a repeating decimal. So you gotta remember what I said in the directions. It wants 3 decimal places. So you would have 13.63, and then it's got the bar over both. So the next number would be a 6 again. Okay. And then for D, it's the range, correct? So the range is highest minus low. So 21 minus 7, which is 14. Okay. So does that look a little familiar? Mean, median,
Yeah.
mountain range?
A little bit.
Okay. I know that's something that I know you started at least in middle school, if not before. Okay. I know you started at least in middle school, if not before that. So, because I've taught it, I don't know how many times. I've taught middle school and high school forever. So, all right. We good? We got number 5 down?
Yes, ma'am.
All right, let's do this. Yeah, we still got time. We'll get through number 6 and then I'll have number 7. Okay, number 6. Says Sarah measured the following amounts of rain that fell at her house for a month. 1.03, 2.3, 1.45, 1.26, 1.8, 1.13, and 2.0. So our first question is the mode. Is there any number that was repeated in her measurements?
No.
None of them are the same, so we just said it has.
No mode.
I mean, got one. They're not one there. Okay. Next one is median, correct? Median, we put them in least to greatest. So the lowest amount of rain looks like 1.03. Then the next one would be 1.13. Then the next one would be 1.26. 1.45. 1.8. 2.0. 2.3. 1, 2, 3, 4, 5, 6, 7. Okay. So I had 7 that time. So if I've got 7, what's my middle number going to be?
1.45.
1.45, the one in the middle. Okay. Now, to find the mean, we add them all up and divide by 7, since there were 7 data values total. So we'll do that real quick. We're going to take those numbers that I wrote over there. Are y'all getting 10.97? Because I don't trust those bad notes because I was coughing in the middle of it. Yeah?
Yeah, that's what I got.
Okay. And so then when you divide that by 7, you get this lovely long repeating decimal. So remember, we're keeping 3 places behind the decimal point. So the 7 is the number 3 places behind the decimal point. Is the 1 behind it going to make the 7 change?
No.
No, it's going to stay the same. So it's 1.567. Okay, that's your average. And then your range is the highest value minus the lowest. So 2.3 minus 1.03.
1.27.
So that's your mean, your median, your mode, and your range. Now, which 3 are considered measures of center? The 3 M's, the mean, the median, and the mode. The range is called a measure of variation because it shows how the data is varied, spread out. Okay, so I'm leaving you with number 7. We'll go over answers to number 7 tomorrow, and then we'll start talking about standard deviation, section 12.2. And then if you paid attention to your lesson plans at all, my schoolworks, then we'll review all those sections, and then you'll do quiz over those, and we'll be good. Okay. But what does everybody need to try to make sure they remember to take today?
Test.
Quiz. Test.
Test. After I end the meeting, I'll go over there and I'll change it. So if you already took it, but you think you want to try again after I went over those examples, then you'll be able to log in and try it again. Okay, so make sure you have down what we got done today. And like I said, we'll finish up 7 and do 12.2 tomorrow. Go take your test, do well. Be good.
Okay.
Bye.
Bye.